Hello students, now we will learn about force and pressure. Have you seen this picture before? This picture defines itself the definition of force. Simple, the push or pull acting on a body is called force. You can say force is an effort of push or pull on a body. That means we can say without an interaction, the force cannot be applied to change the state of an object. A football player is applying force to catch the ball. In the second figure, a hockey player strikes the ball with the hockey to push the ball. Here we will see the effects of contact force. First is it can make an object move. मतलब हम किसी भी object को move करा सकते हैं. See in the figure. Now the second one, it can make a moving object stop. मतलब हम किसी भी moving object को रोक सकते हैं. Now see in the figure. Next, third is it can change the speed of a moving object. मतलब हम किसी भी moving object की speed को कम या ज़्यादा कर सकते हैं. It can change the direction of a moving object. We can change the direction also. And the last, it can change the shape of an object. That means we can change the shape of an object by applying some force. Now see the example here. Here we will learn about resultant force. Means when two or more than two forces are acting in the same direction, or when two or more than two forces are acting in the opposite direction. We will study about both the cases one by one. In this picture, the two boys are acting the force in the same direction, that is x and y. You can see very clearly. So what will be the resultant force? The resultant force will be calculated by adding both the forces. What will happen if the two boys are acting the force in the opposite direction? So the resultant force is found to be the difference between the two forces. That means when the two forces are acting in opposite direction, we will do the difference of each other. Now we will see the examples. Let us see with the examples. Here we are taking two forces, 10 Newton and 20 Newton. Both the forces are acting in the same direction. So what will be the resultant force, student? The resultant force will be the 30 Newton. That means we can calculate it by adding the forces. Why? Because they are applying in the same direction. Now we will take another examples. If the two forces are acting in the different directions or in the opposite direction, that is 20 Newton and 50 Newton. What will be the resultant force, students? The resultant force will be the difference between the two forces. That means it will be 30 newtons. 50 Newton minus 20 Newton equals to 30 Newton. Now students, this is your turn. Now tell me what will be the force between these two forces. As you can see, both the forces are acting in the opposite direction. The resultant force will be the difference between the two forces. That means 3 Newton minus 3 Newton will be equal to 0 Newton. As now we have studied the forces. Now we will learn about types of forces. There are two types of forces, contact forces and non-contact forces. Examples that you can see very easily. Now see the contact forces. The types of contact forces are muscular force and the frictional force, and the types of non-contact forces are magnetic force, electrostatic force and the gravitational force. Let us revise the summary of the force. Look around yourself and tell how many types of forces are acting there. Hello students, in this video we will learn about pressure and its unit, their applications, atmospheric pressure, liquid pressure and many more. Now we will talk about pressure. You know there are two factors on which the effect of force applied, that is force and area, or you can say the other two factors are the magnitude of force applied or the area over which the force is applied. There are two factors on which the pressure depends. So the formula of pressure is force upon area, or you can say in very simple words, the force acting per unit area is called pressure. Now the formula for finding the pressure is force upon area. Force will be represented by capital F and area will be represented by capital A. And the unit of force we all know, Newton, and the unit of area is meter square. So the unit of pressure will be Newton per meter square. Newton upon meter square is also called Pascal, P-A-S-C-A-L. We will learn about some applications of pressure. You know, students, why coolies carrying load on their head always keep a thick round padded piece of cloth on their head under the load? Just think about it. Now, because this helps them in two ways. First, it keeps the load away from the head skin, which is also good. And the second one, it increases the area of contact with the weight from the load. Just because of that, reducing pressure will be there on their head. Now for the same reasons, tractors have big wheels with broad tires. Just because of that, they will not sink into the ground. Now the next example is school bag is provided with a broad strap. Why? Because it makes easier to carry the bag since the pressure from the weight of the bag is distributed along a large area of the strap and student's shoulder will not get hurt. Now we will learn about another pressure, that is atmospheric pressure. You know, air surrounding the earth is atmosphere, and air occupies space and has weight. Now we have learned that any object which has weight exerts pressure, so air therefore exerts pressure. It is called atmospheric pressure. Now we will learn some applications of atmospheric pressure. You can see that boy, he is using the straw for drinking the water. When he will suck that with the help of straw, that air inside the straw is removed and leaving a low pressure area. And the higher atmospheric pressure acts on the surface of the water and pushed drinks into the straw. Now see the second one. Have you seen that sucker hook ever? If your answer is yes, then you know how it's working. Now I am telling. See, when the sucker hook is pressed, the air inside is forced out and leaving a low pressure area. And the higher external atmospheric pressure outside pressed down on the hook and makes it stick firmly to the wall. Now see the drinking straw. You normally use a drinking straw to drink fruit juice, water, etc. But when you suck air at the upper end of the straw with your mouth, the pressure of the air inside the straw is reduced. जब हम एयर को सक करते हैं अपर एंड से, तो अंदर का जो प्रेशर होता है स्ट्रॉ का वो कम हो जाता है. अंदर का कम होने की वजह से बाहर का एटमॉस्फेरिक प्रेशर ज़्यादा हो जाता है. सो द ग्रेटर एटमॉस्फेरिक प्रेशर एक्टिंग ऑन द सरफेस ऑफ द फ्रूट जूस pushes the fruit juice cup into the straw to your mouth. Look at the figure very carefully. Now we all know very well. What is it, class? This is syringe. Who used it? Used by a doctor. Yes, but how it's work? When we dip a syringe in a liquid and pull its piston, the pressure inside the syringe gets reduced. So, the atmospheric pressure acting on the surface of the liquid is more in comparison to the air pressure in the syringe. Thus, it pushes the liquid up into the syringe. This is the working of the syringe, how it works. Now we will read about the pressure exerted by the liquids. We all know all the liquids have weight. So, when you pour a liquid into a vessel, the weight of liquid contained in the vessel exerts pressure on its wall and bottom also. Now we will see the different examples of that. You see the dam, the wall of dam is made thicker at the bottom because water pressure increases with depth. So a thicker wall can withstand a greater pressure extended by the water at greater depth. In this figure, we can see that liquid exert pressure on the walls of the container. Liquids exert pressure on the walls of the container. Sideways pressure exerted by a liquid on the walls of the container is called its lateral pressure, sidewise pressure. The rubber balloon bulges more on adding more water. The reason behind bulging of rubber balloon is that the depth of the water column increases on adding more water. The pressure increases. This shows the lateral pressure increases with depth. In this activity, we will see the pressure increases with depth. Now as you can see, we have done 3 holes. The depth of water near first hole is less, so the water comes out from first hole with the less pressure. It falls near the base of the vessel. The depth of water near second hole is greater than, so the water comes out with the greater pressure from hole and falls further away from the base of the plastic bottle. देख सकते हैं जैसे जैसे डेप्थ बढ़ती जा रही है वैसे वैसे वाटर का प्रेशर बढ़ता जा रहा है. नाउ सी द थर्ड होल. हियर द डेप्थ ऑफ द वाटर इज ग्रेटेस्ट, सो द वाटर कम्स आउट विद द ग्रेटेस्ट प्रेशर एंड गोज फारदेस्ट फ्रॉम द plastic bottle, or you can say the container. So what will be the final conclusion? That means the pressure of a liquid increases with the depth. Students, see in that figure, we had taken a plastic bottle and we have done 3 holes all around near the bottom of the bottle. Now fill the plastic bottle with water. Now remove the tape. Now students, can you observe the jets of water coming out of the holes fall at the same distance? जैसा हम देख रहे हैं कि बॉटल्स के सभी होल्स में से पानी सेम प्रेशर से हमारा बाहर आ रहा है. दैट मीन्स लिक्विड्स एक्सर्ट इक्वल प्रेशर एट द सेम डेप्थ. यदि डेप्थ होल्स की सेम है तो वाटर हमारा सेम प्रेशर से बाहर आएगा. We can summarize all the 3 activities that pressure depends on depth, not shape. Means pressure depth पर depend होता है ना कि shapes पर. All these containers are having the same height, therefore the pressure at the bottom of each is the same. The shape doesn't matter. We can see the summary of the pressure. We all know pressure, we have already studied. The force acting per unit area is called its pressure. And what will be the units of the pressure? The unit of pressure will be Newton per meter square, that is Pascal, and it is denoted by PA, capital P and the small a. And it's depend on force and area. Some pressures, example in daily life are: school bags have wider straps, buildings have wider foundation. Because of that wider, the pressure will be less, so the object or the thing will not sink into the ground. Next, sharp knife cuts better than the blunt knife. Next one, easier to walk on sand with flat shoes rather than shoe with the sharp heels, because in the heels area will be lesser, so the pressure will be more. Now students, before starting another topic, first we will do the quick revision of force. So a force is a push or pull that causes an object to move faster or slower, stop, change direction, or change shapes or shape. Without force, nothing would ever move. Now pressure. We have already read that pressure is defined as per unit area. That means force upon area. So the unit of pressure will be Newton per meter square, or you can say Pascal. And pressure depends on 2 factors. First, force. Second, area. As pressure increases, surface area decreases. Now we will study about types of forces. There are 2 types of forces, contact forces and non-contact forces. Now we will study one by one. As we can see in the picture, the forces experienced by bodies when they are in physical contact with each other are called contact forces. It is of two types, muscular force and frictional force. And what are the non-contact forces? The forces experienced by bodies even if they are not in physical contact with each other. And its types are magnetic force, electrostatic force and gravitational force. Now we will study one by one. So here it is first, muscular force. The force resulting due to the action of muscles. Here the most important one is muscles. So the force which is experienced by muscles is called muscular force. As you can see in the diagram, a boy is pushing the box with the help of muscular force. Now again we will study the force applied using parts of the body like arms or legs is called muscular force. Example, while playing cricket or football, players apply muscular force on the ball. Force applied through the use of animals like bullocks, horses, elephants is also muscular force. Now the another force is mechanical force. The force applied by using machines is called mechanical force. Example, this type of force is used in most of the commonly used machines like pump, vehicles like tractors, etc. So these are the top 10 muscular exercises which you can do at your home and keep your body healthy as well as fit. Like climbing wall, curl-ups, V-sit, plank, bridge, wall sit, arm hang. We will learn another force, that is frictional force. What is frictional force? It is present everywhere in our daily life. It is simply impossible to reduce it completely. So, the force acting along the two surfaces in contact which opposes the motion of one body over the other is called the force of friction. What causes frictional force? So due to the presence of irregularities, frictional force will be happened. There are many types of force of friction like rolling friction, sliding friction, static friction, flute friction. In summarized form, a force that resists motion between two objects in motion that are touching. Some examples are a runner's shoes and the running surface. Ice that is not enough friction provides too much friction. Example, air hockey table. Now I am giving one example. Suppose you are riding a bicycle. Bicycle starts moving with a speed. Stop pedaling. The bicycle slows down. Yes, if you do not pedal it again, it comes to a state of rest. So what stops its motion? Yes, frictional force stops its motion. Now the another force is spring force. So what is a spring force? It is when an object is pushed together, then when pressure taken away, it pops back to its normal self. Now we are studying about non-contact force. So the non-contact force don't have to have an effect. They work over a distance or field of influence. Or if we will talk in simpler words, that is the force extended by an object on another object from a distance is called the non-contact force. Non-contact force is a force applied to an object by another body that is not in direct contact with it. Non-contact forces come into play when objects do not have any physical contact between them or when a force is applied without any interaction. See, what is it? Yes, it is a magnet. And which force it is applying? It is applying a magnetic force. So now students, we will learn about the magnetic force. The amount of magnetic force depends on distance. That is, closer magnets are, the stronger the force. On a magnet, The force is the strongest at both the poles, north and south. Like poles repel and opposite poles attract. Means if the poles will be like north and south, they will repel each other. And opposite poles attract. Means north-south pole or south-north pole will attract to each other. If you break a magnet in half, you will get two magnets. The another force is gravitational force. Yes, it was Sir Isaac Newton who proposed for the first time that every object having mass exerts a pull force on another object, even if not connected to each other, which is called gravitational force. Or you can say force with which Earth pulls everything towards itself is called gravitational force. It is a force of attraction between particles of matter. Example, a ball thrown up returns back to the earth. Due to which force? Yes, gravitational force. Now, do you know why the leaves of fruits fall to the ground when they detached from the plant? Yes, this is because of gravitational force. So, the force due to Earth's attraction is called the gravitational force. This is an example of non-contact force. Yes, see the picture? A ball and a feather falls downward due to the force of gravity or gravitational force. In short, when we drop an object, it leaves the state of rest and starts moving toward the ground. The force that puts an object into its motion is called gravity. It is a non-contact force. The force of gravity is a non-contact force that attracts object towards the earth. It can be stronger or weaker depending on an object mass and its distance from the earth. Gravity is stronger on objects that have got less mass. The gravity is stronger on objects that are near the earth. It's weaker on objects that are far from the earth. Now we will study one amazing fact, that is, a waterfall in Hawaii sometimes goes up instead of down. Amazing, no? Now we will read about electrostatic force. In the electrostatic force, like charges repel and unlike charges attract each other. Now how does this force act if charges are not in contact? Due to the presence of electric field. Electric force is one of four fundamental forces, and the electric force is a field force. The electric force is the result of the interaction between the electric charges, that is positive charge or negative charge. Can you see that picture? In this activity, a boy is rubbing a balloon on head, and after rubbing it will produce some charge and it will stick to the wall. In this activity, run a comb made of plastic through your dry hair. Bring the comb over the bits of paper. Now you will find the bits of paper being pulled towards the comb. On running the comb through dry hair, an electric charge is generated on the comb. This charge is called electrostatic charge. That is, and force from it comes into play even when the two bodies are not in contact with each other. Now, the flute pressure. The size of the force arrow in this diagram show that greater pressure is exerted by the flute as you go deeper in the flute. Now here some important words. First, lubricant. Lubricant changes sliding friction into a fluid friction. In this picture, when released hydrogen balloons rise high up in the sky because of the force of thrust. Now here we are going to solve some numericals. First, a solid body weight 200 Newton. When placed on a wooden plank, the area of contact is found to be 5 meters square. So find the pressure exerted by the solid body on the wooden blank. So what we have to find? We have to find the pressure in this question. In this question, the given values are force 200 Newton and area 5 meters square. Now we have to calculate the pressure. So we will put the formula of pressure, that is force upon area. So when we put the values of force and area in the formula, then we will get the 40 Newton per meter square, or you can say 40 Pascal. Numerical, a brick is 30 cm long, 10 cm wide and 10 cm thick. It weighs 24 Newton and is lying on the ground. Find the pressure exerted by the brick on the ground. So here the given values are force, that is 24 Newton, but area is not given. So first we have to calculate the area of brick. So brick will be in the form of rectangle, so length into breadth. So when we will multiply the length and the breadth of the brick, we will get the area of one brick. Multiply 30 cm by 10 cm. First we will convert into the meter, then we will get the 0.03 meter square. So now we will put the formula of pressure, that is force upon area. So now put the values, and after putting the value of force and area in the formula, you will get the answer that will be equal to 800 Newton per meter square or 800 Pascal. Now students, solve both the numericals in your notebook. Now we are going to start numericals. Question first is, a solid body weighs 200 Newton. When placed on a wooden plank, the area of contact is found to be 5 meters square. Find the pressure exerted by the solid body on the wooden plank. So here we are having force and the area, and what we have to calculate? We have to calculate the pressure. So here force is 200 Newton and area will be 5 meters square. What we have to calculate? We have to calculate the pressure. But we have already learned in the chapter that pressure will be equal to force upon area. So we will put the values of force and area from here in the formula. So see, pressure is equals to force. How much? 200 Newton. And area is 5 meter square. So now we will solve it. When we will do the divide, then you will get 5 4s are 20, 40 Newton per meter square, or you can say 40 Pascal, because we know 1 Newton per meter square is equals to 1 Pascal. So 40 Newton per meter square will be equal to the 40 Pascal. So here is the solution. Now the question number 2 is, calculate the pressure. Again you have to calculate the pressure if a force of 6 Newton is applied over an area of 1 meter square. So force is 6 Newton and the area is 1 meter square. So first we will write the given. Force, how much force? That is 6 Newton, and area is equals to 1 meter square. What we have to calculate? We have to calculate the pressure. So we know that pressure equals to force upon area, equals to force how much? 6 Newton and area 1 meter square. When we divide, then we will get 6 Newton per meter square, or you can say 6 Pascal. So here we will get the pressure which will be equal to 6 Pascal when the force will be 6 Newton and the area of contact will be 1 meter. Now the question number 3 is calculate the force applied that can exert a pressure of 8 Pascal on an area of 152 centimeter square. In this question, we have to calculate the force where the pressure 8 Pascal and the area 152 centimeter square is given. So first we will write the given things. Pressure 8 Pascal, area equals to 152 centimeter square. What we have to calculate? We have to calculate the force. We know that pressure is equals to force upon area. But here the pressure and area is given and we have to calculate the force. So first we will find the formula for force. We will do the cross multiply of pressure and area. So force will be equals to pressure multiplied by area. Now we will write the value of pressure and area in this formula. Pressure is 8 Pascal, area is 152 centimeter square. But first we have to calculate this centimeter square into meter square. Now we know that how we will convert it. See, we know that 1 centimeter is equals to 1 upon 100 meter. Like if 1 meter is equals to 100 centimeter, so 1 centimeter will be equals to 1 upon 100 meter. But for what we have to calculate? We have to calculate centimeter square. So 1 centimeter square equals to 1 centimeter into 1 centimeter. 1 into 1, 1, and centimeter into centimeter is equals to centimeter square. But we know 1 centimeter is equals to 1 upon 100 meter. Same 1 centimeter equals to 1 upon 100 meter. Now 1 into 1, 1, 100 into 100, 10,000, and m into m, that is meter into meter, is equals to meter square. So 1 centimeter square is equals to 1 upon 10,000 meter square, or you can write 0.0001 meter square. Like 1 centimeter is equals to 1 upon 100 meter, same 1 centimeter square will be equals to 1 upon 10,000 meter square, or you can say 0.0001 meter square. But we have to calculate for 152 centimeter square. So here 152 centimeter square will be equals to 152 divided by 10,000 meter square. So when you will do the divide 152 by 10,000, you will get 0.0152 meter square. So we will put the required value of pressure and area in the formula. So force will be equals to 8 multiplied by 0.0152, that is 0.1216 Newton. Why we have written Newton here? Because unit of force is Newton. So the required answer will be 0.1216 Newton. See again, we have to calculate the force here. Pressure and area was given. First we will write given pressure and area. Then we have to calculate the force. We know that pressure is equals to force upon area. So we will find for force, we will do the cross multiply pressure into area. So we will write the values. Pressure is 8 Pascal, area is 152 centimeter square. First we have to convert this centimeter square into meter square. So 1 centimeter is equals to 1 upon 100 meter. So 1 centimeter square is equals to 1 centimeter into 1 centimeter, or you can write 1 upon 100 meter into 1 upon 100 meter. So it will be 1 upon 10,000 meter square, or you can say 0.0001 meter square. Now we will convert 152 centimeter square into meter square. So 152 centimeter square is equals to 152 divided by 10,000 meter square. So you will get 0.0152 meter square. Now we will put the values of pressure and area into the formula. So force is equals to 8 into 0.0152, that will be 0.1216 Newton. So this is the required answer. Next question is question number 4. A brick is 32 cm long, 10 cm wide and 10 cm thick. A brick which we are having, that is 32 cm long, 10 cm wide and 10 cm thick. It weighs 16 Newton. Force कितना है? 16 Newton and is lying on the ground. Find the pressure exerted by the brick on the ground. That means you have to calculate the pressure which is exerted by the brick on the ground. So we are having length, width and thickness of a brick. So first we have to calculate the area, then only we will able to find the solution of that question. So given is length of brick, that is 32 centimeter. So first we will convert centimeter into meter. So what the result will come? It will be 0.32 meter. Width of brick, that is 10 centimeter, and when we will convert into meter, the digit will come 0.1 meter. Thickness of brick, that is 10 centimeter, and then we will convert into meter, the result will 0.1 meter. So now we are having length, width and thickness of a brick in meter. Now we have to calculate the area of the brick. So when you put the brick on the ground, only the two things will come in the contact of brick, length and width. So length is 0.032 and width is 0.1. When we will do the multiply of both the digits, you will get 0.032 meter square. Now the force is 16 Newton. Now what we have to calculate? We have to calculate the pressure is equals to force upon area. Force is 16 Newton and the area is 0.032 meter square. Now we have to divide. So 16 divided by 0.032. So here the three digits will come. So it will be 16, 3 zeros and 32. Do the divide. 16 1 16 and 16 2 times is 32. Again there it will be 1000 divided by 2. So when we will do the divide, you will get 500 Pascal. Now I am again explaining. A brick is 32 centimeter long, 10 centimeter wide and 10 centimeter is thick. It weighs 16 Newton and is lying on the ground. Find the pressure exerted by the brick on the ground. So first we will write the given. Length is 32 centimeter, that will be 0.32 meter. Width of brick is 10 centimeter, that will be equal to 0.1 meter. Next, thickness of a brick, that is 10 centimeter, so that will be also 0.1 meter. Now first we will calculate the area. So formula will be length into breadth, 0.32 multiplied by 0.1. When you will do the multiply, you will get 0.032 meter square. So now the force is 16 Newton. So force is 16 Newton. Pressure is equals to force upon area. Force is 16 Newton and 0.032 meter square. So when we will divide 16 by 0.032, you will get then you will get 500 Pascal. Now, the next question is, in the game of tug of war, 3 girls of team A pull the rope with the forces 80 Newton, 100 Newton, 120 Newton. Means tug of war game में 2 teams are there, team A, team B. In the team A, 3 girls are there who are pulling the forces with 80 Newton, 100 Newton and 120 Newton. In the team B, 3 girls pull the rope with forces 85 Newton, 105 Newton and 125 Newton. Similarly, in the team B, 3 girls are there who are pulling the rope with 85 Newton, 105 Newton and 125 Newton. What is the resultant force? You have to find the resultant force. Which team is the winner? And कौन सी team हमारी winner होगी? Now start the solution. See, here tug of war game is there. In team A, 3 girls are here. In team B, 3 girls are there. In the team A, they are applying the force 80 Newton, 100 Newton and 120 Newton. And in the team B, they are applying 85 Newton, 105 Newton and 125 Newton. Now, see the resultant force of team A. 80 Newton plus 100 Newton plus 120 Newton. We will add them for getting the resultant force. So 80 Newton and 100 Newton will be 180 Newton and 180 plus 120 will be 300 Newton. So the total resultant force of team A is 300 Newton. Now see the team B. Resultant force 85 Newton, 105 Newton and 125 Newton. When we add together 85 Newton plus 105 Newton plus 125 Newton, you will get 350 Newton. So team A resultant force is 300 Newton and in team B resultant force is 350 Newton. Now see, who is applying the more force? 300 or 350? Yes, 350 Newton. So team A is applying 300 Newton and team B is applying 350 Newton. So which team will be the winner? The winner team will be team B, who is applying 315 Newton. So team A 300 Newton, team B 315 Newton and कितने ज़्यादा फोर्स ज़्यादा लग रहा है टीम ए के कंपैरिजन में? सो 315 माइनस 300 न्यूटन विल इक्वल्स टू 15 न्यूटन. मीन्स 15 न्यूटन से टीम बी हमारी विनर है. सो टीम बी इज द विनर. Now we will learn how pressure and area are related to each other. As we know, pressure is equals to force upon area. हम जानते हैं pressure is equals to force upon area. So they are inversely related to each other. Pressure and area are inversely related to each other. Means if area will be more, pressure will be less. मतलब यदि एरिया किसी चीज़ का ज़्यादा होगा तो प्रेशर उस चीज़ का कम होगा एंड यदि एरिया कम होगा तो प्रेशर हमारा ज़्यादा होगा. इफ़ एरिया विल बी मोर, pressure will be less. Means more area, less pressure. And if area will be less, pressure will be more. The area कम होगा तो pressure ज़्यादा होगा. Means less area, more pressure. If area will be more, then pressure will be less. And if area will be less, then pressure will be more. That's why this is the reason a school bag has wide straps made of thick cloth, so that the weight of the bag may fall over a large area of the shoulder of the child, producing less pressure on the shoulders, making it more comfortable to carry the heavy school bag.